stop. Before I say another word, touch something metal near you. A doorknob, a laptop hinge, the leg of your chair. Did you feel anything? Maybe a tiny zing, maybe a nothing dramatic. But something happened between you and that object. Charges shifted, electrons rearranged, an invisible force balanced itself through your hand. And here's the strange part. Most people use electricity every day without ever really understanding what it is. They know what electricity does. It lights rooms, charges phones, runs cities, fires neurons, keeps hearts beating. But what is it really? That question gets deep fast. For the next few minutes, we're going to follow the kind of thinking Richard Feynman loved, not memorizing names, not repeating textbook phrases, but looking at what nature actually does. By the end, you'll never look at a light switch, a wall outlet, or even your own heartbeat the same way again. Now, try this. If you have a balloon nearby, blow it up. No balloon? Grab a plastic comb, pen, or ruler. Rub it against your hair, sweater, or a wool blanket for 20 seconds. Really do it. Feel the friction. Feel the slight warmth in your hand. Now bring it slowly near a tiny piece of paper, or close to the hairs on your forearm. Watch what happens. The paper jumps, the hairs rise, something invisible reaches across empty space. That is electricity at its simplest. You created an imbalance of charge, and nature tried to correct it. That tiny pull is related to the same force that lights cities, powers your phone, fires signals in your brain, and helps hold atoms together. Keep that balloon in mind. We'll come back to it. Because if you understand that one moment, charge, imbalance, attraction, correction, you have the seed of almost everything electrical. Now here's where most people get electricity wrong. You were probably taught to imagine electricity like water in a pipe. Electrons rush through a copper wire, flow into a bulb, and make it glow. That picture is useful, but it is incomplete. In a normal metal wire, individual electrons drift incredibly slowly, often fractions of a millimeter per second, slower than a snail, slower than honey dripping from a spoon. So if electricity were simply electrons racing from the switch to the bulb, the light would not turn on instantly. But it does. Why? Because the energy is not just carried by individual electrons traveling from one end of the wire to the other. The energy is carried by the electromagnetic field. When you close a circuit, an electric field forms through the circuit and around the conductors. That field pushes on charges throughout the wire. The signal moves through the circuit at a large fraction of the speed of light. The electrons move slowly. The electrical influence moves fast. Think of a long tube filled with marbles. Push one marble into one end, and another marble pops out the other end almost immediately. No single marble traveled the whole length instantly, but the push did. That is closer to what happens in a circuit. The wire guides the energy. The charges respond to the field. The field does the real work. This is why Feynman cared so much about fields. A field is not just a diagram in a textbook. It is a way nature stores and transfers energy through space. Around a wire carrying current, there are electric and magnetic fields. Together, they describe where energy is going. The wire matters. The electrons matter. But the invisible field around them matters just as much. That is the part most people never learn. Now let's make this concrete. When you flip a light switch, here's what actually happens. First, you complete a circuit. That means there is now a closed path from the power source, through the wire, through the bulb, and back again. Second, the electric field changes through the circuit. That change travels extremely fast. Third, free electrons inside the metal respond to that field. They begin drifting and jiggling. Fourth, inside the bulb or LED, electrical energy is converted into light and heat. The bulb does not light because one heroic electron sprinted from the switch to the lamp. It lights because the electromagnetic system responded almost all at once. That is the deeper picture. Electricity is not just stuff moving in wires. It is charge, fields, motion, energy, and matter all interacting. And once you see that, the world starts to look different. AC current, the kind in your walls, makes this even stranger. In many countries, wall current alternates 50 or 60 times per second. That means the electrons in the wire do not travel one long journey from the power plant into your laptop. They mostly wiggle back and forth, and yet your refrigerator runs. your charger works, your screen glows. Because again, the useful energy is transferred through the electromagnetic system, not by individual electrons making a grand road trip. Now step back. Humans have been noticing this mystery for thousands of years. The ancient Greeks found that rubbing amber with fur made it attract dust and feathers. The Greek word for amber was electron. That is where the word electricity comes from. Ancient people also knew about electric fish. The electric catfish of the Nile could deliver shocks powerful enough to be remembered, feared, and sometimes used in early healing practices. Long before wires, batteries, motors, and power grids, humans were already meeting electricity through friction, lightning, and living creatures. They did not have the equations, but they saw the behavior. And that was exactly the kind of thing Feynman respected. There is a famous story about Feynman and his father. When Richard was young, other children were taught the names of birds. But his father taught him something deeper. Knowing the name of a bird is not the same as understanding the bird. You can know what people call it in 10 languages, and still know nothing about how it flies, eats, moves, survives, or behaves. That lesson shaped Feynman's mind. Do not just memorize the label. Look at the thing. Electricity is the same. You can memorize voltage equals current times resistance, but that is not the same as understanding it. Voltage is like electrical pressure, a push created by difference. Current is the movement of charge. Resistance is what makes that movement harder. A thin wire resists more than a thick wire. A hot filament resists and glows. A short circuit gives current an easy path and can become dangerous fast. Once you feel the relationships, the formulas stop being dead symbols. They become compressed experience. Now, why should you care? You are probably not building a power plant. But this matters. First, understanding electricity makes the invisible less intimidating. Wi-Fi, Bluetooth, microwaves, radio, chargers, batteries. Most people treat them like magic or threats. But they are not magic. They are fields, waves, circuits, energy, and matter behaving according to rules. When you understand the rules, you become harder to manipulate with fear. Second, you become a better troubleshooter. Why does a charger get warm? Because electrical energy is being lost as heat through resistance and inefficiency. Why do devices slow down when hot? Because heat affects electronic components, increases resistance in some paths, and forces systems to protect themselves. Why does unplugging and replugging sometimes fix a device? Because it resets stored charge states, clears temporary circuit conditions, and often restarts the software controlling the hardware. Not magic. Systems. Third, understanding gives you leverage. Every time something complex clicks, your brain becomes better at learning the next complex thing. That is the real reward. Not trivia, power. When you understand one invisible system, you become more confident facing the next one. And electricity is one of the best systems to start with, because it is everywhere. It is in your walls, it is in storms, it is in your phone, and it is inside you, right now. Your heart is electrical. Every beat begins with a wave of charged particles moving across cell membranes. Sodium, potassium, calcium, tiny ions shifting in carefully timed patterns. That electrical wave tells your heart muscle when to contract. That is why an EKG works. That is why a defibrillator can restart a dangerous rhythm. Your brain is electrical too. Billions of neurons communicate through electrical impulses and chemical signals. Every thought, memory, fear, idea, and decision depends on patterns of activity moving through living tissue. You are not just using electricity. You are running on it, not like a machine made of copper wires. Like a living storm of charge, chemistry, and information. Your nervous system is constantly sending signals. Your heart listens. Your muscles respond. Your senses translate light, pressure, sound, and temperature into electrical patterns your brain can understand. You are an electrical organism walking through an electrical universe, and you can influence that system. Take a slow breath. Inhale gently. Now exhale longer than you inhaled. Do it again. Slow breathing can shift your nervous system toward a calmer state. Your heart rhythm changes. Your vagus nerve helps regulate the conversation between brain and body. This is not magic. It is biology, and biology uses electricity. Cold water on your face can trigger reflexes that slow the heart. Touch, breath, temperature, movement, All of these affect the electrical and chemical signaling inside you. Even intuition has a physical side. Your gut and brain communicate constantly through nerves, hormones, and chemical signals. Sometimes your body detects patterns before your conscious mind has words for them. That something feels off sensation is not supernatural. It is your nervous system processing information below the surface. Electricity is not just out there. It is part of how you are aware at all. Now go back to the balloon. You rubbed plastic against hair and created a charge imbalance. The paper lifted, the hairs rose. A tiny invisible field changed the behavior of matter. That same basic idea scales upward. From static sparks to batteries to motors to lightning to radio waves to computers to neurons to heartbeats. Different systems, same universe, same rules wearing different costumes. So here is your assignment. Tonight, before bed, do 3 things. First, flip a light switch and pause for 1 second. Remember, the electrons are not sprinting across the room. The field changes, the charges respond, and energy moves through the system. Second, place your hand on your chest and feel your heartbeat. Remember, every beat is electrical. The same universe that powers the bulb is also keeping time inside your ribs. Third, pick one thing tomorrow that you do not understand. Anything. How a refrigerator works. Why the sky is blue. How a battery stores energy. Why your dog tilts its head when you speak. Then go find out. Not the name, not the shallow answer, the thing itself. That is the Feynman method. Look closely. Ask what is really happening. Follow the mechanism until the magic becomes understandable, because you have a choice. You can move through life surrounded by magic boxes, screens, wires, outlets, signals, and systems you never question. Or you can pull one thread, and behind that thread, find a universe humming with structure. That tiny spark from metal, that balloon pulling paper, that heartbeat under your hand. They are all invitations. The universe is not hiding. It is demonstrating. Go find out.